Hi friends, see today I'll be starting another new chapter that is called as heat transfer. Okay, heat transfer. See, the other name for this heat transfer is also called as thermal properties of matter. Part 2. Thermal properties of matter part 2. This is the other name, but in general we'll be calling as heat transfer. In general we'll be calling as heat transfer. Okay. So in this chapter we'll be dealing, that is, how the heat is transferred, what are the modes of transformation of heat. In general, heat transfer is done by three ways. One is by conduction method, another by convection, and last one by radiation method. So heat can be transferred in three ways. ఒకటి conduction, రెండోది convection, మూడోది radiation. Now first of all let us see what is meant by conduction method. See, in conduction method, see here, in conduction method, suppose if you take metal rod, because we all know all metals are very good conductors of heat and electricity. So if you take a metal rod, this is P end and this is Q end. Suppose this end is heated. Suppose this end is heated, for example. Now what happens? The heat, when the one end is heated, the molecules, the particles will be vibrating. The heat is developed, is transferred gradually to the other end. Okay? Due to the vibration of the particles, what happens? The heat is transferred from one point to another point gradually. And finally what happens? It reaches to the other end. That is why you can see practically sometimes when we are in the kitchen room, suddenly we will be rotating with the spatula, steel spatula, while making curries or water. Suddenly we will leave the hand because the heat is transferred by conduction method. Chala sal man chusa untam. Okay. So from one end to other end, the heat is slowly developed and it is reached to the other end. So this method is called as conduction. Ikkada em javutundi? Because solids, what happens? The atoms and molecules are tightly packed compared to liquids and gases. That is why conduction is more. That is why conduction is more in solids, next in liquids, and least in gases. Okay? So conduction is more in solids, next in liquids, and least in gases. Or gases less than liquid, less than solids. So conduction is more in solids than liquids, than gases. Or you can write in this fashion, relation. Because atoms and molecules are tightly packed in solids. So that is why more conduction is done in solids compared to the liquids and gases. So this is how, due to the vibration of the particles, one particle will be transferred to next particle to the next. Like that, to the other end the heat is transferred. So this is the method of conduction. Now let us go to the second method, that is convection method. Convection method lo ela jarugutundo chuddam. So what is convection method? See, for this I have to take an example of water, boiling water. For example, this is a vessel filled with water. Suppose here it is heated up. Now you can observe one thing. Practically you can observe some molecules are coming down. We can observe practically some molecules are coming down and some molecules are going up. What are these? Water molecules. What are the molecules which are going up and which are coming down? See, as you know, when it starts heating water boiling point is 100 degrees centigrade. So when it starts heating, what happens after getting heated? Hot water have less density compared to the cold water. Cold water have more density. So here if you observe, this is the cold water and this is hot water. So hot water after becoming heated, density becomes less and it goes to the top. and on the top whatever the cold molecules are there, చల్లటి నీరు ఏదైతే ఉందో డెన్సిటీ ఏమవుతుంది, ఎక్కువ ఉంటుంది. సో ఇట్ కమ్స్ డౌన్. సో లైక్ దిస్ the transfer of molecules continuously takes place until the entire water molecules are gets heated up. So here what is happening, from one layer to next layer the heat is transferred gradually. From one layer to the next layer heat is transferred. As an example, if you take the water, so that method is called as convection method. That method is called as convection method. So by the method of convection only heat can be transferred. And higher density, when the density is more it comes down, when the density is less it goes up. There are other examples for convection also you can give. For example, in the construction of the buildings, if you observe, windows are kept. Why windows are kept? Why the windows are kept in the at a height of around like 3 feet above? That means when we are coming from outside, when we open the doors, to get the breeze, cool breeze from outside to inside, we will open the windows. So when you open the windows, cool breeze, చల్లటి గాలికి ఏమవుతుంది, డెన్సిటీ ఎక్కువ ఉంటుంది. సో డెన్సిటీ ఎక్కువ ఏమవుతుంది, it comes from the windows. In the same way, if you observe in kitchen rooms or bathrooms, we will be having exhaust fans. So why the exhaust fans are constructed there or kept there? When hot air, whatever kitchen hot air or bathroom waste hot air is there, its density becomes less and it escapes through the ventilators. So these are another example for convection. So through the exhaust fan, hot air is going outside because it becomes what, less density, and cool breeze having more density comes from the windows into the house. So this is the method of convection. Now let us go to the last one, radiation. What is the method of radiation, of heat transfer? So radiation, if you observe the last process, radiation, this best example is electromagnetic wave, that is sunlight. The rays coming from sunlight, no medium is required. ఎటువంటి medium కూడా అవసరం లేదు. Solid, liquid, gases, it directly enters from the vacuum. Even through vacuum it can travel. Like sound waves or whatever waves, no medium is required. So the best example for radiation means reaching the light directly to the earth's surface. Reaching the light directly to the earth's surface, because in electromagnetic wave, no medium is required. ఎటువంటి medium అవసరం లేదు. That type of heat transfer is called as radiation method. Example, sunlight. Because these are electromagnetic waves, medium ఎటువంటి అవసరం లేదు. Directly it can travel without any medium. Okay? So this is how different modes of transfer of heat. Okay? Now let us see the next thing in this one, that is called as variable state and steady state. Okay na? Second one, that is variable state, and next one is steady state or streamline state. Now what is variable state and steady state? We will try to understand by giving some examples. For example, this is an iron rod. Variable state of heat, in other words. Okay? Steady state of heat, that is Q or dq of heat. Now let us take this example. This is Pn, this is Qn. I'll take one more point also. This is called a junction. Now what is variable state? For example, you start heating this rod. When you give heat, the heat is, because by conduction method heat is transferred by the vibration of the molecules. So from one part to direct, and finally what happens? It reaches to the junction, then to the other end. Now for example, let us assume here temperature, say for example 10 degrees centigrade. Here let it be around say 3 degrees centigrade, and here let us say 1 degree centigrade. Please make sure these are rough values, not a practical value, rough values, to understand better the unsteady state, that is variable state. When you are supplying heat here, let us assume when a heat is given for some time, Let the temperature at P end be 10 degree, junction 3 degrees and Q end 1 degree. Now you increase still further. This is number 1 anukundam idi. Now still you increase the heat. Now let us in the next state, let the heat has changed like this in this fashion. This is the second one. Now when increases, let it has gone to, for example, say 20 degrees centigrade at Pn, and here around say 5 degrees centigrade at junction, and here let us take 3 degrees. Okay, when still further you are giving heat, let the second position be 20 degrees, 5 degrees and 3 degrees. Okay, still it is unsteady. Let us go to the next one. Still the heat is given out. Okay, P and Q and junction. Now let us, it has reached to say like 70 degrees centigrade, and here like say 40 degrees centigrade, and here 10 degrees. These are rough examples to explain the unsteady state of heat flow I am telling. Now for example, still heat is given. Suppose P end is maintained at 70 only, junction is maintained at 40 degrees centigrade, Q end is maintained at 10 degrees centigrade. Then what happens? This variable state has gone. That means this here, whatever conductor, iron rod, cannot take more heat now. It has become steady now. So up to here, if you can see, these two examples, these are unsteady. Unsteady means what? Heat is continuously varying due to the supply of heat from outside. Here you can see 10, 3, 1. Next 20, 5 and 3. So after some time, after hours together, if continuously heat is given, then it will attain a steady state. Steady state of heat. So what is meant by steady state? That means maintaining constant temperature at the junction, this end or that end, or at the intermediate points. That means here if you observe, P end temperature, P end is greater than junction end. You can see 70, 40. Junction end is greater than Q end. So this is called as a steady state temperature. So in an iron rod, if it is attaining some steady state, then you can see this temperature is greater than junction, junction temperature is greater than other end temperature. Okay. So after attaining steady state, if some more heat is given out also, it won't take the heat, it won't increase the heat also. It will maintain same temperature at the ends. That type of state is called as steady state. In unsteady state, the temperature go on changing from the ends. You can see the examples on the top. 10 it has become 20, 20 it may become 30, 30 it may become 40, like that. But after attaining the steady state, the temperature remains constant. Please make a note. So this is the meaning of variable and steady state of temperature. Clear? Please note down, these are very, very important in the IP examination, and also in entrance examinations they are asking regularly regarding the steady state and variable state. Now let us go still further to understand in a better manner. Okay. Now what we will do is, we will try to understand in better manner, that is the next concept in this one, that is called as coefficient of thermal conductivity. Next one is coefficient of thermal conductivity. This is generally written as K. Let us try to understand what is meant by coefficient of thermal conductivity. Okay. Now for this, what I will do, I will take an iron rod again, and please make a note, when I am explaining coefficient of thermal conductivity is not unsteady, it is steady state. Under steady state condition, please, steady state condition, that means the temperatures are constant. For example, here T1 degree centigrade, here T2 degree centigrade, and at the junction let it be some theta degree centigrade or T3, any temperature you can take. Now it is steady state, that means T1 is greater than, okay, theta, greater than T2. After attaining steady state only, you have to consider the thermal conductivity. Now, for example, some heat is given, for example, Q heat for the iron rod. Now, what is the relation when the heat is flowing? See, Q is directly proportional to area of cross section of the rod. Q directly proportional to the time of flow. Q is inversely proportional to length of the rod. Are you following the points? How the heat is going inside the rod, it depends upon area of cross section of the rod, directly proportional to the time, how much time it is flowing, the heat, dq or q, and inversely proportional to length of the rod. Suppose if L is the length. So these are the parameters affecting the heat. Now combining all equations, you have Q proportional to, okay, A T by L. And of course, one more also is there, you have forgotten, it is directly proportional to temperature difference, please, delta T. This is, you can take it as 4, temperature difference, because already you know, it is a steady state, it is maintaining T1, T2, junction at theta. So one more is there, that is combination delta T. Okay, the delta T and nt temperature difference, higher minus lower, okay, which is higher out of all these three? This is higher. Next is this junction, and last is that one. So I put that also. Now you can see Q, remove the proportion, introduce a constant K, A, delta T, small t by, this is not T here, L here, okay, because already T you have written, this is L. So this is the final equation of the expression for coefficient of thermal conductivity. So from this you have what is Q heat, K coefficient constant of proportionality. This after removing the proportionality, introduce a constant of proportionality, that is K. This is called as coefficient of thermal conductivity of the material. A, area of the cross section, delta T, temperature difference. Delta T is difference in the temperature, either T1 minus T2 or T1 minus, whatever way you can take. If you take between these two, it is T1 minus theta, because these are higher. If you take between these, then T1 minus T2, because T1 is greater than T2. And L is length of the conductor, T is the time, how much time the heat is flowing. Now from this you can find out what is K. K is nothing but Q into L by A delta T small t. So this is the equation for coefficient of thermal conductivity of the material. So Q and heat, what is the SI unit? Joules. Length, meter. Area, meter square. Temperature, you can write Kelvin or also theta. Kelvin రాసేద్దాం. Okay, units kada Kelvin రాద్దాం. Kelvin రాయాలి. Time, seconds. Meter. What is joule per second? Joule per second, nothing but power. Units into watts. Joule per second kada, rate of doing work. So watt by oka meter ikkada Kelvin. Okay, so please check it. What is the SI unit of thermal conductivity is watt per meter Kelvin, degree Kelvin, because it's a temperature difference. This is the SI unit. Okay, examination they are asking. So SI unit of K is watt per meter Kelvin. You can also find out the dimension formula also, please. So I'll write the dimension formula also, please. See here. Sometimes in the examination they may be asking that also, because already in first chapter units and dimensions already I told you how to find out dimension formula. You can even find a dimension formula for K. So what is dimension? Identi work done kada, work ante enti m L square T power minus square, because work is equal to force and displacement, ml T power minus 2 into L. So L square T power minus 2 into L by area L square. Temperature difference dimension formula generally we will take theta. Okay, లేదా K కూడా రాసుకోవచ్చు. Time into T. L square gets cancelled. So K is equal to m power 1. Okay, ఇంకేమైనా పైన L, that is L power 1. Theta, temperature difference, that is temperature, either K power minus 1 or theta power minus 1. Temperature, the time పైకి వెళ్ళిపోతే మైనస్ అవుతుంది, T power minus 3. So this is the dimension formula for coefficient of thermal conductivity. M power 1, L power 1, theta పైకి వెళ్ళిపోయింది temperature -1 or K power -1, okay, and T power ఇది పైకి వెళ్ళిపోతే -1 కూడా -T అవుతుంది. This is the dimension formula. Clear? So please write down this one, very very important. Written? Right. So we have learned about what is coefficient of thermal conductivity, okay, and also the units also written, SI units, and also the dimension formula. Now how to define coefficient of thermal conductivity, the material? How to define? K ఎలా define చేయొచ్చు? How to define? How to define K? So to define K, you have to make the remaining all items 1 unit. For example, L is equal to 1 meter, area 1 meter square, or you can make 1 unit also, meter square or 1 unit, you can even take 1 unit. If length is equal to 1 unit, area 1 unit, time 1 second, delta T 1 degree centigrade difference, put all the values in the formula. K is equal to Q into 1 by 1 into 1, temperature difference 1 into 1 second. What happened then? K is almost equal to Q. So K almost equal to Q అయిపోయిందంటే అర్థం ఏంటి? Coefficient of thermal conductivity is that quantity of heat flowing in a conductor of length 1 unit over area of 1 unit over a temperature difference of 1 degree centigrade over a time of 1 second. This is how you will define K. Coefficient thermal conductivity ఏమైంది? If all are making 1 unit, or you can even take 1 meter also. ఇది 1 meter square అయితే definition మారుతుంది. I have taken 1 unit. So if length is 1 unit, area of cross section is 1 unit, and delta T 1 degree centigrade over a time of 1 second, and that is equal to the coefficient of thermal conductivity. It is that quantity of heat flowing in a conductor having a length 1 unit over area of 1 unit, temperature difference of 1 degree centigrade, time of 1 second. Clear? Yes. Now let us go still further. We have defined K also. We have given units for K, coefficient of thermal conductivity. Let us go still further in the topic. Now let us see the next item, that is thermal resistance. Okay. Now let us see what is meant by thermal resistance. Before going to thermal resistance, let us see what is heat current. Heat current ante enti? This is also called as power, rate of doing work. Rate of doing work. Now just now we have given for a steady state condition, what is Q? Q is equal to Ka into delta T into small t by L. Now how you will define power or heat current? That means rate of flow of heat divided with time t. So Q by T is equal to Ka into delta T by L. What is this rate of flow of heat, rate of doing work? Power. So this I can write it as capital H. So heat, this is also called as what? Heat current. Heat is flowing, just like electricity. When current is flowing inside any material wire, you are saying current electricity. Same way, when heat is flowing, it can be called as heat current. So Q by T I can write as H. This is also called as power. So H is equal to Ka into delta T by L. This H is called as heat current. Rate of flowing of heat current, just like power. Okay. Now this expression is very very important. As and when you can change this one. See here how I will change. Heat current, I can change it as, this one you can see, I can express in this fashion delta T by L by Ka. Because when you take Ka to the numerator again, it becomes same equation. Ka delta T. ఒకసారి దీన్ని గమనించండి. L by Ka, length of the rod, thermal conductivity, area of cross section. This is called as thermal resistance. R thermal. Therefore, heat current kada, I can write it as either H or you can, but if you don't use I, because already in current electricity we are using as I, so better use H only. So heat current H is equal to delta T, temperature difference by, this value is nothing but what? R thermal. R thermal. Please watch carefully. This formula is almost equal to Ohm's law. As you know, resistance is there, current electricity potential is there, plus minus current is going. If R is there, what is V? IR. Or what is V by R? I. So here it is electrical current in Ohm's law, current electricity. What is the formula? I is equal to potential difference by R. So here what? Heat current and temperature difference by R thermal. So as you can see, both are almost equal. In Ohm's law, I told you in current electricity, I is equal to V by R, potential difference by R, or V is equal to IR. This is electric current. But here, heat current means temperature difference by R thermal, where R thermal is equal to L by Ka. So heat current is also called as power, rate of flow of heat in a conductor. Clear? Please note down. Very, very important it is, heat current. Now, let us see the next thing, that is, in the examination they are also asking some graphs also, that is temperature gradient. Let us see what is meant by temperature gradient. Let us see what is meant by this temperature. అంటే సింపుల్గా చెప్పాలంటే dt by dx. Simply you can say dt by dx or dt by dl. For example, you know this is iron rod, this is one end, P end, Q end, and we know after attaining steady state, for example 70, gradually what happens, this will be maintained 70 only. For example here 60, 50, for example here 40, 30, 20, for example here 10 degrees centigrade. For example, all these are some values, rough values I am giving, degree centigrade, degree centigrade, degree centigrade. So gradually if you can see, the value is decreasing. It will be more at the one end, junction it will be constant, and also least at the other end. Now for example, for this if you draw a graph, that means this is the length of the rod, for example, length of the rod, L. Here length of the rod is taken as X. Here L is taken as X. Okay? Now if you observe carefully, here the temperature if is taken on y-axis, T on y-axis, temperature T taken on y-axis. If you see the graph is, you can see decreasing. So name in the temperature 70, 60, 50, 40, gradually it is decreasing. So you can see the negative slope here. It is decreasing, slope is negative. So what is tan theta here? Tan theta m is equal to negative. So what is the slope? Opposite by adjacent. You can take anywhere, opposite by adjacent. Opposite value and some temperature value, opposite by adjacent. What is opposite value? dt. And what is adjacent? Displacement. Either you can write dl or dx. And here because it is decreasing, the value is negative slope. Slope tan theta is equal to negative value. చూడండి value తగ్గిపోతుంది కదా. Opposite by adjacent, opposite by adjacent, opposite by adjacent. Opposite value means what? Temperature, dt. By adjacent means what? dx. So and it is negative slope, decreasing. Okay? So that dt by dl or dx is called as temperature gradient. Examination అడుగుతున్నారు అప్పుడప్పుడు entrance లో, it is called as temperature gradient. Okay, dt by dx. Here the slope is negative. So you can see the decreasing, value is decreasing. That is called as temperature gradient. So already I have given an equation for you. Q is equal to Ka into delta T into T by L, and from this Q by T, which is called as heat current, is equal to Ka into delta T by L. You can observe here H is equal to K into A. What is this dt by L? Gradient. Okay, so dt by L and the temperature gradient, that is nothing but delta T or dt by dx. Okay, dt by dx or delta T by dx. Okay, so that is called as temperature gradient. Sometimes you can write delta T by delta x, or you can also write dt by dx, where x is the length of the rod or L is length of the rod. So like this also you can express the heat current value, because Q by T is equal to heat current. Okay, so in this fashion you can explain the theory of temperature gradient by using a graph. Clear all of you now? Now let us go to the next one, that is series connection of rods. Series connection of rods. Very, very important. Please note down. Let us go to the next one. Series connection of rods. See, in the examination, sometimes they will be asking for 4 marks derivation IPE. And whereas in entrance examination, whatever final value you got, that value you can remember and you can use in the numericals. Okay. So now let us derive an equation for series connection of rods. And thereby we will be getting some value of for coefficient of thermal conductivity. Let us see what will be the value, final value. Put the heading all of you, series connection of rods. Okay na? Right. Now the next one is series connection of rods. Now how you will series connect? For example, see, this is a rod, one rod. Okay, let this length be L1 and let the resistance be R1. Let another rod of length say L2. Let this length be L2. Let the resistance be R2. And you can see rare cases it will be area difference, but maximum areas will be same. So I will take area, same area, whatever area here, same area. Even if they give unequal areas also you can get. First let us derive the equation. So resistance R1, R2. Now I will combine this one as a single. I will combine this one as a single. I will combine this one for effective value. Because as just now I told you, area is same. If they give different area also will get it. Okay. Let the temperature here be T1 degrees centigrade or Kelvin, whatever value. T2 degrees centigrade. Let the junction temperature be some theta degree centigrade. Okay. Junction temperature is very, very important. Okay. That also you have to consider. So you can T1 and make a note, just because it's a steady flow, please. Steady flow of heat. Under those conditions only you can derive, okay, not unsteady. So here temperature T1 degree centigrade, T2 degree centigrade. Now these two rods have combined together. Now what is the total length it will become now? What is the total length? L1 plus L2 combination. And for here, let this coefficient of thermal conductivity be K1 and it be K2. And here let it be K suffix E. That is effective thermal conductivity coefficient. And what will be the area? Because just now I told you area is same, area will not be changing. Clear? Now already I told you how to calculate the heat current, because in series connection you can see whatever heat is flowing in this direction, same heat will be here, same heat also here. Here also you can say whatever heat is flowing, same heat will be here. ఎంతైతే dq వెళ్తుందో ఈ ఎండ్లో same dq will be flowing. So whatever heat is flowing will be constant because it's a series connection. So what is heat current formula in general? Delta T by R thermal, I told you. Delta T, temperature difference by R thermal. Okay? If you want this part, you can calculate heat current here. You can calculate here. Whatever heat going here, same heat here also. So how will get heat here? Delta T. That means T1 minus theta by R thermal. If you want this point, see here. Whatever heat here, see. I can what is the temperature difference between here? T1 minus theta by R thermal. What is R thermal here? That is nothing but resistance. Whatever resistance is assumed here, R1. Or you can also write like this. Instead of R1, you can also write what is here? R thermal. R1 thermal, I can write as L by Ka. That means L1 by K1 here, I can write in that fashion. In the same way, here also you can get heat. What is heat for the second rod? Same, delta T by this thing. What is temperature difference? You can heat temperature get theta minus T2. This is higher, this is lower. By R thermal. What will be R thermal for here? R2 thermal ఎంత అవుతుంది? Okay, I can write as R2 or theta minus T2 by L2 by L by Ka. K2A. Like this I can express the values. But as you know in current density, what is the series connection formula? Effective value, series connection, you will get R is equal to, Re is equal to R1 plus R2. In series connection, what is the value effective in current density? R1 plus R2. But what is Re, effective value for this one? What is the effective value for this one? I will get R thermal. I will get it. So R thermal is equal to L by Ka. What is L here? L1 plus L2 by Ka. K and then the K area is constant. Here is equal to what is R1? L1 by Ka. K and the first rod and the K1A plus what is R2? L by K and L2 by K2 into A. You can see the common A term is there. Now I want Ke. So from this, what is Ke value? Ke. K and the effective value of conductivity, coefficient conductivity ఎంత వస్తుంది? L1 plus L2 by L1 by K1 plus L2 by K2. So this is the derived formula. And when two rods are connected in series connection, heat is constant. Whatever Q is going, same Q will be going to the throughout. So and you can apply the current density formula. Re is equal to R1 plus R2. So what is Re here? L by Ka. And L and ikkada effective length. L1 plus L2 by Ka. Area is constant here. Same area I am taking. If area is different also, you can put the value, you will get some values. But same area we are taken. And what is R1? L by Ka. That is L1 by K1A. So when you add up, finally I got the derivation. Effective, that is coefficient of thermal conductivity. Effective value when rods are in series is L1 plus L2 by L1 by K1 plus L2 by K2. You can even extend this formula for rods. Suppose more ఎవరైనా అడగవచ్చు, సార్ ఒకవేళ 2 rods కాదు 3, 4 ఉన్నాయి, అప్పుడు ఏం చేస్తారు? Then you can extend this formula like this. Now I'll write down. Suppose if more number of rods are there, suppose if more number of rods are there, 2 కన్నా ఎక్కువ ఉన్నప్పుడు ఏం చేస్తా formula? It goes like this. Effective conductivity coefficient is given by L1 plus L2 plus L3 plus dot 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 Ln by denominator lo L1 by K1 plus L2 by K2 L3 by K3 dot 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 Ln by Kn. Like this you can extend the formula. If more number of rods are ఇక్కడ ఒకటి 2 rods తీసుకున్నాం, అందుకే L1 plus L2 by L1 by K1 plus L2 by K2. Number of rods are increasing more than 2. L1 plus L2 plus L3 dot 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 Ln by L1 by K1 plus L2 by K2 plus L3 by K3 plus dot 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 Ln by Kn. Okay, so ఈ విధంగా మీరు తీసుకోవచ్చు. Copy it, right? Now let us go to the next one, that is parallel connection. Okay, series connection అయిపోయింది కదా, parallel connection ఏమవుతుందో చూద్దాం. Parallel connection of rods. So these are very very important for 4 marks derivations in IPE, and whereas in the examination entrance like NEET and MSET, you can remember the formula L1 plus L2 by L1 by K1 plus L2 by K2. You need not remember all the derivation. Only in the examination of IPE the derivations are asking. Now let us go to the next one, that is parallel connection. ఒకవేళ ఎగ్జామినేషన్లో మీకు parallel connection అడిగాడు, parallel connection of rods, derivation for K effective value, coefficient of thermal conductivity. So ముందు అసలు parallel connection అంటే ఏంటి చూద్దాం. For example, this is one iron rod, okay, but here you can observe one thing, in parallel connection length will be same, area may be changing, same length, area may be changing, A1 and A2. Sometimes area may be taken as same also, please. Okay, parallel లో ఏరియా మారొచ్చు కూడా, ఐ మీన్ సేమ్గా ఉండొచ్చు, కానీ ఇక్కడ నేను ఏం చేస్తాను, ఏరియా డిఫరెంట్ తీసుకుని A1 A2, అండ్ దీనిది కండక్టివిటీ వాల్యూ K1 అనుకుందాం, ఇది K2 అనుకుందాం, A1 A2. Now I am combining this one as a single. When I am combining, you can see what happened to the area. Length remains same, length change avadu, area changes. What is the total area now? A1 plus A2. What is the area? A1 plus A2, total area. What is the area here? A1 plus A2. Now we will apply the same formula here. In series connection, already I told you in current electricity, 1 by R is equal to 1 by R1 plus 1 by R2. Okay? So here you apply the same formula. What is 1 by RE? How will you get the R thermal here? L by L means what? This length, effective length. L by KA. L by KA. What is area here? Sum of two areas, that is A1 plus A2 is equal to 1 by R1. How will you get 1 by R1? R1 again, R thermal, L by KA. That means L by K1 A1. Okay? Plus 1 by what is R2? R thermal, L by K. L is constant ikkada. L by K2 A2. Now this will go to the top. KE A1 plus A2 by 1 is equal to K1 A1 by L. L is there here, forgotten. Plus K2 A2 by L. Now you can take the common term L on both sides. రెండు సైడ్ L కామన్ వచ్చింది తీసేయండి. ఓకే, now what is left over? I want K suffix E, effective conductivity, thermal conductivity due to the parallel connection. సో ఎంత అవుతుంది, ఇది K effective E, KE అనుకుందాం. ఓకేనా, ఇది కాంబినేషన్ A1 plus A2 area. Equal area also you can do it by using this formula. So K effective is equal to what happens? K1 A1 plus K2 A2 by A1 plus A2. So this is the value, derivation value for effective value of conductivity, thermal conductivity when rods are connected in parallel. Parallel ఏమవుతుంది చూడండి ఒకసారి, మర్చిపోయారు మీరు చెప్పడం. Parallel లో whatever heat is going is distributed as H1 and H2, and here whatever heat is given same is going. ఇక్కడ చూడండి, heat H is given as H1 H2 అంటే what is H? Total heat H1 plus H2. That means H1 value, heat going in the first rod plus heat going in the second rod. I will get heat going in first rod, తెలుసు కదా, delta T by R thermal, అలాగే delta T by R thermal. By this formula also you can get it. So this is the final formula, K1 A1 plus K2 A2 by A1 plus A2. For example, if A1 is equal to A2 in this formula, అప్పుడు ఏమవుతుంది, K effective value is equal to K1 A plus K2 A by A1 plus A2 అంటే A plus A. So what happened now? You take A, first you write down A into K1 plus K2 by 2A. So A gets cancelled. What is the value? If A1 is equal to area of 1 is equal to area 2 in parallel, then the answer is what? K1 plus K2 by 2. ఎంత వచ్చింది? K1 plus K2 by 2 is effective thermal conductivity value. Okay, please note down. So this is how you will be deriving the derivations for series connection and parallel connection. Please note down. Very important, the derivations in IP 4 marks. Very important. Now we will try to do a small numerical. We will try to do a small numerical problem. Okay, చిన్న ప్రాబ్లం ఒకటి చేద్దాం మనం, న్యూమరికల్ ప్రాబ్లము. చూడండి అది ఏంటనేది. See here, small numerical, and that problem goes like this. For example, there are 3 rods of same length. For example, there are 3 rods, same length. Same length means resistance will be also same, and they are kept in this fashion. Okay, and they are given the temperature also. Here the temperature end is 0 degrees centigrade, here 80 degrees centigrade, and here 80 degrees centigrade. Now the question is, what is the temperature at the junction? Let the temperature be theta degree centigrade. The question is, 3 equal rods, same length, so resistance also same. Okay, same length, so therefore the resistance also same. Equal rods, identical rods, diameter kuda same. Now here the temperature is 80, junction not given, here 0 degrees. So he is asking you what is the temperature at the junction. Very easily you know, always the temperature falls, goes from high to low. So ikkada temperature ekku kabatti ikkadi nunchi temperature indulo veltundi. Here also. So if you observe carefully, what is the connection here? Series or parallel? Parallel connection. Chudandi. For example, here H1 heat, here H1 heat coming. So what happens? H is equal to H1 plus H2. Parallel connection. Indirectly is given parallel connection. So for example, here heat is coming H1. Always heat flows from high level to low level. So ikkadi nunchi ikkada vastundi. Idi H1, idi kuda H2. Okay, H2 current, H2 heat or heat current, rate of flow of heat. So it is coming in this fashion. Now apply the formula here. Here 0 degree. Where is the high temperature? Temperature high here. Next high here. Least here. So here I can apply. For this rod, how can I apply? Theta high temperature minus. What is heat current here? What is heat current? This one. ఇందులో heat ఎంత వెళ్తుంది? H కదా. So H value ఎలా వస్తుంది? What is the formula? H is equal to delta T by R thermal కదా formula. So H, this value is equal to delta T. Delta T అంటే ఎంత? Theta minus 0 by R thermal. What is the resistance here? R. Same rods. Is equal to, what is H1? Who is at higher temperature? 80. So 80 minus theta by R thermal. R plus what is H2? 80 minus again same. 80 minus theta by R thermal. So R cancel. So theta minus 0 is equal to ఎంత అవుతుంది? 180 plus 80 160 minus 2 theta. ఆ 2 theta ఇటుగా పట్టుకొచ్చేసి ఎంత అవుతుంది? 2 theta plus theta 3 theta is equal to 160. Theta is equal to 160 by 3. So 3 5s are 15, 1 is there 10, 3 3s are 9, 1 is there 0.033. So what is the answer? 53.33 degrees centigrade. So the temperature at the junction ఎంత వస్తుంది? 53.33 degrees centigrades. So this is how you have to solve by using the heat current formula. If identical rods are given same length, if values are given as 80 or 180 or whatever value may be, how to calculate the junction temperature is by using this is a parallel connection, H is equal to H1 plus H2 formula. Okay, and by using heat current formula you can calculate the value. Clear? Right. Now these are the things you have to learn, very very important in series connection and parallel connection. Very very important formulas. Okay. Now after this we are left over with, okay, problem is also there, and we are having one more derivation also, very very important I think. Okay, growth of ice on the lake or pond, and after that I think we are having last point, that is radiation. Okay, so we are left over with only one point now, that is growth of ice. So I will do one thing, otherwise we will complete of growth of ice and we will go for the radiation better there, otherwise. Okay, so in the examination IP also they are asking this derivation, that is growth of ice on a lake or pond. Next derivation, growth of ice on lake by pond. This derivation is very very important in IP also they are asking. Okay, so for that I will take some diagram. Let this is some pond or lake, pond by lake. Okay, so water is there, this is water. Let this be 0 degrees centigrade and here 4 degrees centigrade, because you know at 4 degrees centigrade what happens, volume expands. Okay, maximum density. Now from here let this be surface of the lake or pond, this is surface, and let the surface area be A. Surface area is okay. Let the surface area be A. Okay. Let this one be Y. Let this depth be Y, and this one be dy. Okay. Are you following? Now I am trying to derive an equation for you. 4 marks. Growth of ice on a lake or a pond. You know, already I have discussed, this is the process called as anomalous expansion of water or peculiar behavior of water. In colder countries, when the temperature falls below 4 degrees, 4 degrees కన్నా below పడితే ఏమైంది, గ్రాఫ్లో చూసాం, volume expands. When volume expands, density decreases because volume and density are inversely proportional. So when density decreases, what happens? On the top layer, because of the less temperature, ice is formed. Ice, big ice blocks are formed, and it will be floating on the surface because of less density. And down, aquatic culture will be surviving, fishes. So that one already derived in part 1. Now regarding that one, I will derive one equation for growth of ice, that is dy by dt. At what rate the ice is growing on the lake or a pond. Now you can see this is the lake or pond. This is the 0 degrees centigrade. Completely water is there, and this is the low temperature 4 degrees. Now for example, this is surface and this is outer temperature, surrounding temperature. Let it be at -0 minus theta తీసుకుందాం, minus theta degree centigrade. Okay, అంటే ఇది ఎక్కువ ఉంది టెంపరేచర్ 0 degree, దిస్ ఇస్ ఎట్ లెస్ టెంపరేచర్. ఓకేనా, ఎందుకు లెస్ ఉంది కాబట్టి ఐస్ ఫామ్ అవుతుంది. బికాజ్ ద టెంపరేచర్ ఇస్ నెగిటివ్, ఐస్ ఇస్ ఫార్మింగ్ దేర్. సో ఇక్కడ ఏమైంది, ఇనిషియల్లీ యూ కెన్ సీ దిస్ వై, initially y is the depth of the ice, formed. Initially y is the depth of the ice formed. This is the ice formed. You can see this is ice formed because of the negative temperature. Already it is formed. Y is the depth of the ice formed. Now what we are trying to explain, I am watching some time. Okay, so in a time dt time, more how much ice is formed on the lake? And dt time lo inka enta ice form avutundi when the temperature is lowered. So what I'll assume is, let this small dy thickness of ice is formed in a dt time, and the mass is also say dm. Are you following the point here? Let this is already formed, y depth. Now what I'll take is, let dm mass of ice is formed at a dt time. Okay, so how much layer it is formed? dy thickness it is formed. So you can observe one point, when ice is forming, heat is absorbed or heat is released? Heat is released. So here what happened? Heat is released. Heat is released by the ice. So when heat is released, what happens? It is given out here. It is going up. Heat is released. So it is conducted to the top. So here you can observe what happens. Calorimetry principle you can observe here. Calorimetry can apply cheyachchu. Heat lost is equal to heat gain. So here what happens? Because of the formation of the ice there, dy thickness ice, heat is released, not absorbed. Okay, because ice form ayindi ikkada. Ice melt avaledu. Ice form ayindi. So heat is released here, and it is conducted toward the top area, towards this one. So heat release is equal to heat conducted. What is the formula here? Heat released is equal to heat conducted to the top. So what is heat release? We know what is heat release. Q is equal to ml, latent heat of fusion. Heat release అంటే ఇక్కడ ఏమవుతుంది? హీట్ రిలీజ్ అయిపోయి మెల్ట్ అయిపోతుంది ఐస్, ఇప్పుడు అంటే పైకి వెళ్ళిపోతుంది, కండక్ట్ అవుతుంది. సో Q is equal to ml. What is m here? dm mass. Mass ఎంత అనుకున్నాం? dm mass here. So what is the mass of the ice released? Q is equal to ml. So dm into L, where L is the latent heat of fusion of ice, 80 calorie per gram CGS lo. So heat released by the ice is equal to heat conducted. What is conducted formula? So heat conducted Q is equal to Ka into delta T into T by L. This is the formula. Heat conducted. So therefore K, coefficient of thermal conductor of ice, A, surface area of the pond, surface area, okay na, A into delta T ఎంత అవుతుంది? ఎక్కడి నుంచి వెళ్తుంది చూడండి, 0 degree centigrade నుంచి it is going to minus, which is at higher 0. So 0 minus theta, temperature difference, into time కూడా we have thought as small time interval dt by L. What is the length here? Can you tell me length అంటే ఏంటి? ఇక్కడ y కదా. What is the length? You can see. Okay, it is conducting కదా. ఎంత length? y length. Okay, is it clear? So here how much length it is? Is it y or dy? We'll check it. Now here one thing, what is density of the, ఇక్కడ dm mass అనుకున్నాం కదండి. What is the piece length? dm mass అనుకున్నాం, ఫామ్ అయిందన్న dt టైంలో, dm ఫామ్ అయింది. సో వాట్ ఇస్ డెన్సిటీ? డెన్సిటీ ఈజ్ ఈక్వల్ టు మాస్ పర్ వాల్యూమ్, లేదా డెన్సిటీ ఇంటూ వాల్యూమ్ ఈజ్ ఈక్వల్ టు మాస్, లేదా డెన్సిటీ ఇంటూ వాట్ ఈజ్ వాల్యూమ్, ఏరియా ఇంటూ లెంత్. కండక్షన్ పైకి అవుతుంది. సో ఏరియా ఇంటూ లెంత్. లెంత్ అంటే ఇక్కడ ఎంత వేసుకోవాలి? y is equal to dm. Clear? So therefore observe carefully there how much it is going there. Okay, so here dt time lo what is the length? Conduction y conduct అయింది. సో ఇక్కడ ఏంటి? dm mass, I will get it, density is equal to mass per volume, area into length. ఏరియా ఇంటూ లెంత్ అంటే ఎంత? ఇక్కడ dy, area into length anta dy, a dy. You can observe carefully there. Okay, So therefore, if you substitute here in the place of dm, entadi rho a dy, because dy is the length formed during dt time, into capital L is equal to ka into minus plus theta dt by y. A cancel. Now from this equation I will take it as dy by dt. అప్పుడు ఏం మిగిలింది మనకి? పైనేమో k theta, కిందనేమో rho y l. Observe carefully. K theta by rho y l. Observe carefully. dy by dt is equal to k theta by rho y l లేదా rho l y ఏదైనా రాసుకోవచ్చు. rho l y or rho y l ఏదైనా ఒకటే. rho l y or rho y l, anything is right. rho l y. Please observe carefully here. This derivation is very important. IP for 4 marks derivation. ఇక్కడ dy by dt అంటే rate of growth of ice on the pond or lake because of the temperature dropping. In colder countries, temperature drops below 4. Then ice is formed on the top surface. Beneath all water will be there. So, ఈ growth ఎలా జరుగుతుంది with respect to time? dy by dt is equal to coefficient of thermal conductivity of ice k, theta, temperature difference between lower and higher, rho, density of the ice there, l, latent heat of fusion of ice, y, how much length it is growing. Okay, y is how much length growth ice will be growing. So this formula is very important in numericals also. This is the growth of ice on lake or pond. Very important derivation. Please note చేసుకోండి. K theta by rho lv. Okay na? So y also I told you how much ice is formed there. Y is how much ice is formed. That is length of the ice. And remaining all parameters I told you. Sometimes in advanced level examinations like JE, he may be asking in different form also. This derivation is okay for you? Now see, in rare cases, he may be asking in this fashion. That is, see here. Now this equation I can write it like this. dy is equal to k theta by rho ly into dt. In advanced level, he may be asking in a time interval. For example, between y1 to y2, between t1 to t2, how much will be the displacement of the ice? How much ice is formed? అప్పుడు మీరు ఇంటిగ్రేషన్ చేయాలి. From y1 to y2 limits, lower and upper limit dy integration y. అలాగే ఇక్కడ dt, t. ఇవన్నీ కాన్స్టెంట్స్ పక్కన పెట్టండి, dt. From t1 to tt. Okay, t2. This formula also you can use for advanced levels. Time ఇస్తాడు మీకు 2 seconds to 4 seconds. Then the distance ఇచ్చాడు y1 to y2. Then simply integrate the value. You will get the growth of the ice. Okay. So this is the end of the derivation of growth of ice. Then what I will do is, now last one radiation is left over. That radiation I will be discussing in part 2 of heat transfer. Okay. So in part 2, next part 2 of heat transfer, I will be discussing. Small amount is left over, that I will be completing in the next part of heat transfer. Okay.